Venus gleams in the night sky, a beacon so bright it's often mistaken for a star, a plane, or something stranger. But that shimmering point of light hides a truth almost no one has ever seen. Beneath its veil of clouds, Venus is not the serene, glowing orb it appears from Earth. It's a world of unimaginable hostility, a crucible of fire and pressure that defies every expectation of what a planet can be. For centuries, its surface was a mystery, cloaked in an atmosphere so dense it swallowed light itself. No telescope could pierce it, no imagination could fully grasp it. But now, through the courage of machines and the ingenuity of science, we've torn through that veil. What you're about to witness isn't a painting, not a digital render, not a guess. These are the real images of Venus, gritty, unfiltered, captured from the ground, from orbit, and by spacecraft never meant to look at it. This is Venus as it truly is, raw and unapologetic, a planet that challenges everything we thought we knew. The story begins with a gamble against impossible odds. In the 1960s and 70s, Venus was the ultimate test for any machine daring to claim it could survive the cosmos. This wasn't a gentle world like Mars, where rovers could roam for decades. Venus was a furnace, a place where metal melted, circuits fried, and pressure crushed anything foolish enough to land. The atmosphere was a suffocating blanket of carbon dioxide, 92 times denser than Earth's, laced with sulfuric acid and heated to 465 degrees Celsius, hot enough to melt lead. Sending a probe there was like tossing it into a volcano and hoping it would whisper back before it died. But the Soviets, undeterred, threw everything they had at it. From 1961 to 1984, they launched over a dozen probes toward Venus. Most were swallowed by the planet's wrath. Some incinerated on entry, others missed entirely, vanishing into the void. Failure after failure piled up, but they kept trying, driven by a relentless need to know what lay beneath those clouds. Then, in 1975, something extraordinary happened. A probe touched down. It wasn't just a fleeting contact. It survived for 53 minutes, an eternity in Venus's hellscape. That probe sent back the first image ever taken from the surface of another planet. The photo was raw, grainy, black and white, and warped by heat and a tilted camera. It showed a jagged mess of flat rocks, like a quarry abandoned under a suffocating haze. This wasn't the smooth, ethereal Venus of myth. It was brutal, broken, and real. Days later, another probe landed 2,200 kilometers away, lasting 65 minutes and beaming back a similar scene, cracked slabs under a sky that seemed to press down with unbearable weight. These images weren't beautiful. They were profound. They were proof that humanity could reach out and touch a world that seemed untouchable. Capturing stones 38 million kilometers away, with machines that screamed their findings before melting into silence. By 1982, the missions grew bolder. 2 more probes landed, and this time, they didn't just see Venus, they revealed it in ways no one expected. One captured the first color images, painting the planet in a sickly yellow glow, tinged by sulfur dioxide and volcanic fumes. The ground looked like a scorched, interlocking crust, as if the planet had baked itself into a cracked alien pie. Another probe recorded sound, a low, eerie hum of wind, grinding against the lander's hull. A voice from a world that didn't want visitors. It even drilled into the surface, analyzing soil that told stories of lava and unimaginable pressure. These weren't guesses or simulations. They were direct, unfiltered glimpses of a planet that had rejected every other intruder. In those fleeting moments, before the probes succumbed, they showed us Venus's truth, a world not of clouds and beauty, but of violence, heat, and relentless transformation. Seeing Venus's surface directly was only half the battle. The planet's atmosphere is a fortress, a thick shroud of clouds that blocks visible light entirely. From space, Venus looks like a featureless yellowish sphere, a blank canvas that reveals nothing. For decades, that's all we had, a glowing orb that mocked our curiosity. Cameras were useless. Light couldn't penetrate. So science turned to a different tool, radar. By bouncing radio waves off the surface, we could map what light couldn't show. In 1989, a spacecraft was launched to do just that. It wasn't chasing pretty pictures. It was armed with a synthetic aperture radar system designed to pierce the clouds and reveal the planet's bones. Arriving in Venus's orbit in 1990, it began an obsessive task, mapping the surface with relentless precision. Over 4 years, it covered 98% of the planet, achieving a resolution as fine as 100 meters per pixel. The results were staggering. The radar unveiled a world unlike anything we'd imagined. Massive shield volcanoes loomed, dwarfing Earth's largest peaks. Vast lava plains stretched out, not like rivers, but like oceans of molten rock, frozen in time. Strange, miles-wide pancake domes rose from the surface, formed by viscous lava unlike anything on Earth. Fractured terrains looked like the planet was trying to rip itself apart. Highland regions, some soaring 11 kilometers above the lowlands, stood as scarred testaments to a world in chaos. This wasn't Earth's twin. It was a planet caught in geologic madness. The surface appeared young. Crater counts suggested it was only 300 to 500 million years old, a blink in planetary time. That youth hinted at something wild. Venus might have melted itself down, resurfacing everything in a cataclysmic reset. The radar didn't just map a planet, it built a 3D world. Scientists later used the data to create false-color topographic maps, simulating sunlight to reveal valleys, mountains, and fractures. We could virtually walk across Venus, tracing its scars, even if our eyes could never see it directly. The spacecraft's mission was supposed to end sooner, but it defied expectations, orbiting and refining its scans until 1994, when it was deliberately plunged into Venus's atmosphere. A fiery end for a machine that had rewritten our understanding. Its legacy was undeniable. Venus wasn't a smooth, cloudy marble. It was a scarred, volcanic wasteland, shaped by eruptions and crushed by its own weight. But the story didn't stop there. While orbiters mapped from above, scientists on Earth found another way to see Venus, without ever leaving the ground. Using massive radio telescopes, they fired radar pulses across 38 million kilometers, listening for the faint echoes that returned. It was an almost absurd idea, mapping a hidden planet from another world with signals that took minutes to travel and came back as whispers buried in noise. Yet it worked. By the early 2000s, these Earth-based radar systems were producing maps that rivaled orbital scans. They revealed volcanoes, ridges, valleys, and craters with startling clarity. Unlike orbiters, which could only map during their mission, ground-based telescopes could revisit Venus year after year. Comparing images over time, scientists noticed something astonishing. The surface wasn't static. Some areas showed changes, new lava flows, collapsed vents, shifts in texture that couldn't be dismissed as noise. One region, dotted with volcanic features, hinted at recent activity. Scans from 2012 and 2020 showed differences in surface roughness, suggesting fresh eruptions or crustal shifts. These weren't just snapshots, they were evidence of a planet still alive, still moving, still reshaping itself in secret. The echoes from Earth confirmed what orbiters had suggested. Venus wasn't a dead world. It was restless, its surface a canvas of ongoing change. The surprises kept coming. In 2020, a spacecraft designed for an entirely different mission, a probe built to dive into the Sun's corona, turned its gaze on Venus during a flyby. Its camera, meant to study solar plasma, wasn't optimized for planets. Yet against all odds, it captured something extraordinary, the first visible light images of Venus's surface. Taken from the planet's night side, the photos showed faint, ghostly outlines of terrain glowing through the haze. This wasn't reflected sunlight, it was thermal emission, light radiated by the planet's scorching rocks in a narrow band of near-infrared and visible spectrum. Ridges, plains, and highlands emerged like shadows, their brightness tied to heat or composition. The images weren't crisp, but they were real, actual photons from Venus's surface hitting a sensor, never meant to see them. The camera also caught a faint, atmospheric glow, a halo of oxygen atoms high above, shimmering like Earth's auroras. It was a glimpse of a planet we thought we could only see with radar. This moment was a revelation. A solar probe, speeding past at 20 kilometers per second, had done the impossible. It saw Venus in visible light, something no mission had been designed to do. The images showed a world glowing with its own heat, a planet still active, still radiating energy. The implications were profound. If a camera built for the sun could capture this, what could we achieve with a mission tailored for Venus? The discovery rewrote the rules, proving that even a shrouded world could reveal itself through clever physics and a touch of serendipity. It was a reminder that Venus, for all its secrecy, was starting to yield to our persistence. Then came the evidence that changed everything. In 2023, researchers poring over decades-old radar data noticed something startling. Images of a massive volcanic vent, one of the tallest on Venus, taken 8 months apart, showed a dramatic change. The vent's walls had collapsed, and its floor was flooded with what looked like fresh lava. It wasn't a live eruption, but it was close, a before and after snapshot of a planet still alive. In 2024, another team, using advanced processing, analyzed thousands of radar scans and found more new flows, cracked terrain, deflated domes, as if magma had shifted beneath. These weren't isolated events. Across vast regions, the surface showed signs of recent upheaval. The old assumption that Venus was geologically dead crumbled. This discovery carried weight far beyond new maps. Active volcanoes meant internal heat, a churning mantle, perhaps even tectonic processes like Earth's. It suggested Venus was still venting gases, shaping its atmosphere's chaos. The thick, toxic clouds, with their sulfuric acid and mysterious dark streaks, might be fed by eruptions happening now. Some scientists even revisited a controversial claim from 2020, traces of phosphine, a gas that on Earth is linked to life. While no one is saying Venus harbors life, these volcanic clues fuel speculation about chemical cycles we don't yet understand. The planet's youth, its activity, its strange atmosphere, all point to a world that's not just a relic, but a living, breathing system. The future is where this story turns from awe to anticipation. New missions are coming, built to answer questions the first probes only dared to ask. One, launching in the early 2030s, will use radar so precise it can detect surface changes smaller than a meter. Another will scan the crust for tectonic shifts, mapping the planet's deep structure. A third will plunge into the atmosphere, sampling its chemistry as it descends. These aren't flybys, they're deep dives, designed to catch Venus in the act. Eruptions, gas plumes, maybe even the faint glow of molten lava. If we see fire on a world we thought was silent, it will rewrite not just Venus's story, but our own. Venus and Earth, so similar in size and origin, took wildly different paths. One became a cradle for life, the other a cauldron of fire. Why? The images we have now, grainy lander photos, stark radar maps, faint visible light glows, are more than data. They're windows into a world that doesn't want to be seen. The lander images show a ground-level truth. Cracked rocks under a crushing sky, captured by machines that died to send them. The radar maps reveal a planet-wide story. Volcanoes, plains, and fractures that speak of a violent past and a restless present. The visible light photos, improbable and faint, show Venus glowing with its own heat, a planet alive in ways we never expected. These aren't polished or beautiful, they're raw, uncomfortable, real. They strip away the myth of Venus as a serene sister to Earth and show it for what it is, a world of fire, pressure, and unrelenting change. What makes these images so powerful is their honesty. They don't flatter or simplify. The lander photos, with their warped lenses and yellow hairs, show a landscape forged in extremes, where rocks crack under heat and pressure. The radar maps, in their grayscale or false-color starkness, trace a planet's scars. Volcanoes larger than Everest, plains smoother than deserts, terrains folded like crumpled paper. The visible light images, faint and ghostly, reveal a surface radiating its own energy, a glow that shouldn't be visible, but is. Together, they tell a story not of a single moment, but of layers, ground, topography, and atmosphere, each peeling back a piece of Venus's truth. The questions Venus raises are as vast as its volcanoes. Did it once have oceans, a climate where life could have taken hold? What catastrophe turned it into this inferno? Could Earth, so close in size and orbit, ever follow the same path? Every image, every scan, every echo brings us closer to answers. The coming missions will go further, watching for eruptions, mapping the crust, sniffing the air for clues. They'll ask not just what Venus is, but what it was, and what it might mean for us. This isn't just about a planet, it's about understanding the razor's edge between habitability and oblivion. Venus has hidden for too long, but it's starting to speak. Its voice is in the cracked rocks, the glowing plains, the restless vents. It's in the radar waves that cross millions of kilometers and the faint light that shouldn't be seen but is. This is no longer a planet of myth or mystery. It's real, captured in images that don't lie. And as we stand on the cusp of new discoveries, one thing is clear. Venus isn't just a point of light in the sky. It's a warning, a challenge, and a call to keep looking. Because the more we see, the more we realize how much there is to know.